science of that when we come back from the short break. Thank you very much.
Bruce Lipton.
Okay, thank you. Thank you very much for staying. I know it's getting later, but we'll try and finish this because this is, as Doug said, this is the most relevant part, because once we understand how the machine works, now let's talk about how the machine is programmed to work, and this becomes more relevant for us. And I said there are several things I'm going to talk about, but the first one I want to talk about is what I call assumption number one, and that is the one that said biological processes employ Newtonian physics. And we talked about that, and what we said is that Newtonian mechanisms are based on the universe being a matter machine, so that all you have to study is the matter, that it's a complex machine that if you take it apart and study the pieces, then you can understand how the complex machine works by looking at all the individual pieces, and then by being able to do that, you should be able to create new pieces and control the expression of the machine. Remember, that was the mission statement of science, to control and dominate nature. Well, that means the ability to understand how the machine works and then replace the parts. Well, the issue about that is revealed in this article, which was in Science. This is a mainstream journal, conventional biomedical journal, and I'll read it for you in case you can't see it. And it says, but perhaps the biggest challenge to reductionism, the concept of taking it apart and looking at it, it says, but perhaps the biggest challenge to reductionism comes from the concept of information. Remember, information are signals, okay? The signals that control. And here's what I'm going to emphasize it now. It says, in biology, information is carried and received by molecules, which is fully consistent with the reductionist principles of physics and chemistry. The point it says is this, that in biology, information is only in the molecules. If it's only in the molecules, then to adjust your body, I provide you with new molecules, and there, of course, is the foundation of the pharmaceutical industry to make new molecules to adjust your body. But the issue is information only carried in molecules? Well, in old-fashioned Newtonian physics it is, but not in our new physics. The old Newtonian mechanism said the universe was made out of matter. It's just like a machine. But in 1925, we reestablished a new view of how the universe works. And it says this, that in quantum mechanics, the universe is actually made out of energy. What you look at as physical matter at the very atomic structure doesn't physically exist. That the atoms are not real physical at all. Even though I can show you an electron micrograph of atoms, they're pairs of atoms where the arrows are indicating right there. Here's an interesting truth. If I take a camera and start to get closer and closer and closer to that atom, that actually I could go all the way through the atom from one side to the other side and not see anything. The closer you get to the atom, the less you see. And the reason is this, that the atom is not physical. The atom is a vortex of energy. So inside the atom is nothing real structural. So we're familiar with the atom on the left, the Newtonian atom. All of us saw it, marbles, ball bearings going around like solar systems and all that. But here's the atom of today, the quantum atom. And it's not missing, it's actually there. But the issue is a quantum atom has no physical structure to it. But the energy behaves as matter in an atom. But so the point about it is this. The world of medicine is based on Newtonian mechanics. It's based on materialism. But in quantum mechanics, it says matter isn't the end point. Energy is the end point. According to quantum physics, you can never understand the universe if you don't incorporate the role of energy in the process, because energy shapes matter. Number two, the concept of reductionism. Sure, I can study atoms, how they connect to each other, and look at that as physical atoms, but the point is, atoms are not like marbles. Here's the edge of this marble, here's the edge of that marble. I can say this marble is separated from this marble, but the reality is this, they're energy. There are no edges to them. So this atom and this atom are always touching and entangled with each other. The atoms that are in your body are energy waves that are involved with the energy all around you as well. You cannot get out of the energy field. There is no way to study an individual without studying the energy. So the concept of reductionism gives way to this new understanding which biology is beginning to adjust to. It's called holism. It says everything is entangled. I can't just look at one little part and say that part is wrong, because that part is connected to all the other parts. So the bottom line is this, we're pulling back, rather than looking at reductionism, we're pulling back and looking at holism. How your health is not just a matter of the physical structure in here. How your health is related, it's related to the environment and how you fit into the environment. So a doctor or a health practitioner much concerned about how actions in your family dynamics, community dynamics, work dynamics, because all of those are contributing to the functional structure of your own body. So the fact is, looking at little things and blaming little points has been an error, because we now recognize that reductionism is not the way of seeing science, it's holism. And then, of course, the concept of determinism falls out completely, because you can't ever determine all the interacting events that lead to a process. And the result is, actually, there's a theory in quantum physics, not a theory, it's a principle called the principle of uncertainty by Heisenberg. And it says the more accurate you try to measure something, other parameters of that disappear, so that you can never actually determine anything. So we've tried to live best we can, but we can't ever really come to that belief of controlling in fullest how we live on this planet. I bring this paper up, Detecting Individual Atoms and Molecules with Lasers. Every atom or molecule emits and absorbs light of characteristic wavelengths. That's the first line under the title. What does it mean? Every atom and molecule emits energy. In other words, every atom is vibrating and giving off an energy frequency. But not only that, every atom is also receiving energy. So every atom or molecule in your body is not only giving off energy, but it's receiving energy, and the energy it receives will alter its expression. So what does that mean at the level of the atom? Well, let me step in front of this and show you this. If I stand here, and if you can see my hand, and let's say that the red side of this nucleus, this is a theoretical model of an atom. We're still using the physical structure right now. Let's say the red side of the nucleus is negative, and the green side is positive. If I put a voltmeter over at this side of the atom, what am I going to read, positive or negative? Okay, did I say the red side was positive? What did I say? Red is positive. So what am I going to read over here? Positive. And if I read it on the other side, what is it going to be? Negative. If I read it at the middle, between both of them, think about it for a second, what's the answer? Neutral, because it's between both. Well, the fact is, yes, if I move the voltmeter all the way around, I'll get different voltages. But here's the truth. The atoms actually move themselves, so that I don't have to move them around. The atoms are spinning. Oops, let me go back. I'll go back to that one again. The atoms are spinning, and as they spin, if I put a voltmeter out of here, then what's it going to do? Positive and negative. Color is positive and negative. So what am I reading? Positive, negative, positive, negative, positive, negative. If I attach a voltmeter, it looks like that. If I now get a printout of the voltmeter, what does it look like? Then you see this wave, that there's positive and negative, and they vibrate at different frequencies. Each atom has a unique characteristic vibrational frequency, and it broadcasts this because the energy is not held at the edge like here, but the energy travels throughout the environment. So when we read an atom, in the old days in our chemistry books, remember we had atomic mass and atomic structure and, the density of atoms. Now, in the new quantum physics books, when you read about an atom, you read about its electrical charges. Its volts. Atoms are measured by volts. And so what we're looking at is atoms have waves of frequency energy, so each atom vibrates at a frequency. So it's not only emitting a frequency, but atoms can also absorb frequency because energy can be absorbed by other energy. So when we look at this spectrum, this is what we saw in our chemistry books when we went to high school, an atomic spectrum here. So I have different molecules, hydrogen, helium, mercury, uranium, and little color bars. But colors are frequencies. They're vibrational frequencies. What does it say? It says that each atom has a unique frequency vibrational signature that separates it from other atoms. That's how we can tell the composition of planets and stars, because if we read the light emitted from them, the light can be interpreted as to the composition of the planet. So we can read frequency and understand matter through the frequency. Well, the relevance about this is in this picture right here. This is a breast scan. And the question is this: am I actually looking at a picture of the breast, yes or no? Is this an actual photograph of a breast? No, it's an image of the breast. What is it an image of? It's an energy spectrum. And it's interesting. Medicine doesn't recognize the role of energy, but uses all the new quantum physics devices derived to read energy. So PET scans, CAT scans, the MRIs, all those kinds of technologies work on what? Reading the energy. So the relevance is this. They understand that the CAT scan will pick out the tissue there in the center where a cancer is. Well, why do I know that that's a cancer tissue? And the answer is the energy emitted by those cells is different than all the other energy. So when I do an energy scan, I can start to see the character of the cells by the energy they are emitting. Well, what's the relevance? And the answer is this. Conventional medicine would then see this and say, well, then what I have to do is go inside there physically, cut out that bad tissue and remove the bad tissue, only using the energy process for diagnostics. But the bottom line is this, as we showed in the slide about atoms, not only do they emit energy, but they absorb energy. So the interesting part is, rather than physically going in there, it is then possible to put the energy back in to adjust the energy of the cells rather than to destroy the cells.